Greetings and welcome. This is Dr.BDY Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In this session, we will be learning about equilibrium of forces and equilibrium. First, let us understand what the equilibrium of forces is all about. A body is said to be in equilibrium when there is no change in the state of rest under the effect of the forces acting on the body. That is, the resultant is 0. We have already learned that resultant is a single force which can be replaced by the number of forces without changing the effect of the body. Let us say that a body is being applied by number of forces and even then the body is at rest. That is, the body is not moving by the effect of the forces. Then we can say that the body is in equilibrium under the action of forces. It represents that all the forces acted on the body are making the body not to move in any direction. Even when the forces are acting in many directions, that is, the forces are making themselves equivalent. So the ultimate result is that the sum of the forces is becoming 0. Hence, there will be no resultant. That is, the resultant of the forces acting is 0. Let us consider an example of tug of war game. If the force applied by the person on the left is greater than the forces applied by the persons on the right, then the rope will move in the left direction and vice versa. If let us say that the force applied by the single person on the left and 3 persons on the right are equal, then there will be no movement of the rope on either side. That is, the rope is in equilibrium. The force in the left is equating the 3 forces in the right and making the object or body into equilibrium state. Schematically, this event is represented here. Let us say the force applied by the person on left is P and the forces applied by the persons on right be F1, F2 and F3. We can say that if P is equal to F1 plus F2 plus F3, then the system will be in equilibrium. This can be explained like this. If P is equal to F1 plus F2 plus F3, then the system will be in equilibrium. Nothing but there will not be any movement of the object. If at all this is not equal, that is either P is more or F1 plus F2 plus F3 is more, then what happens? The object will tend to move in either direction. So that makes the object not in a equilibrium state. So for understanding this, here let us consider R as the resultant of all the 3 forces acting here. R as the resultant of all the 3 forces F1, F2 and F3. Now, if this object is applied with R and the force that is being applied left side is P, then this object can be termed as the equilibrium positioned object. If this R is greater or lesser than P, then what happens? This object will move in left or right directions. So we can say that if P is equal to R, then the system will be in equilibrium. Let us imagine that there is no force that is being acted here. That there is no force P that is acted here. And because of this applied force F1, F2 and F3, the object is moving in right side direction. Then we have applied, afterwards we have applied a force P which is making this object to take rest or it is not moving anywhere by the application of this force P. So we can say that this P force is making this object to equilibrium state. Hence, this P force can be called as equilibrant. Equilibrant. This P force can be called as equilibrant. So this P, where this P force is equal to R, that means the resultant of F1, F2, F3 is equal to P. Hence this P, which is making the object to in equilibrium state, is called as the equilibrium. Understand carefully. Initially, there is no force that is being applied in the left side direction. Only these three forces are present. When we are applying the force P, the system is getting into equilibrium state. Hence, we can say that this force P, which is making the system into equilibrium state, is called as the equilibrant. So, simply, you can take the definition of equilibrant as the force which makes the system into equilibrium state. This concludes the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.